Okay, number 105, page 458. Oops, my bad. Yeah. So you got 3 minus 2i to the 5, right? Using Demoire's theorem. Okay, step 1. Find out. Sorry, Nilay? Root 13. Everybody with Nilay on that? Yes? Okay. Step 2. Find theta. Yeah. Why not? Sorry? Well, you can graph it either before this or after, right? I mean, because you want to find out where the angle is. Yeah. All right. Okay. My bad. Minus 2. It's out there, right? So in quadrant 2. No, wait. Negative 2, comma 3. Oh, my bad. It's 3, comma negative 2. Oh, my bad. Well, this is Monday morning, okay? This is what happens when you party on the weekend, okay? Yeah. So do not. Well, I went to the Oscar night party, man. I was there. I had to fly in this morning. Yeah, those effects are still lasting. Yeah, you're right. Don't tell Fry that, okay? So that's 3, negative 2. So 3, negative out here. Quadrant 4. Right? So it's going to be some kind of mean A angle. Okay? Because that's not a friendly angle. All right? So I'll just call it theta. All right? And you can get that out of your calculator. Okay? So step 3, your z is going to be equal to root 13 cosine theta plus I sine theta. And theta is going to be in your calculator. Okay? Some radians out there. So let's just leave it like that right now. Okay? Then I need to find z to the 5. Right? So that becomes root 13 to the 5, right? Cosine 5 theta plus I sine 5 theta, right? And then you just chuck this in your calculator. So what you're going to do is you're going to put root 13 in your calculator, raise it to the 5th power, times cosine 5 theta, where you'll get theta from here. You guys want me to follow through with this, or you guys okay on this? As you're looking like it's Monday morning. From there. From Demoire's theorem. What does Demoire say? You multiply the angle by that exponent. No, I'm just leaving everything on the calculator. Because theta is a mean-ass angle. It's not a friendly angle. Sorry? Well, that's what I'm saying. It's going to be a crazy number. My only gotcha on that is that make sure that you have the numbers stored in your calculator. Do not use the 4 decimal places, because if you do, you will not get the answer they have. I don't even think they'll give you the number like that in an angle. The answer in the book is negative 597 minus 122i. Yeah. Well, so let's go work this on the calculator then. Okay, let's go work this on the calculator. Let me make sure my mode is in radian. Doesn't have to be, but let's just keep it in radian. So what do I have? I have a tangent inverse, okay, of negative 2 divided by 3, and I'm going to store this in A. Everybody with me on that? Okay, so just go ahead and enter. Some nasty number. Okay, they use a negative convention. It's okay. Let the calculator do it. It's smart enough to handle it, I believe. Okay, so let's go try it out. So what do I want? I want square root of 13 to the 5th power times cosine alpha A. Everybody with me on that? Yes? No, wait a minute. My bad. What's the mistake here? 5A, thank you. Plus I sine 5A. Is everybody with me on that? Am I effing up in my entries there? Does that look okay? There you go. Boom. Okay. Now, if you didn't store this minus 0.588 into your calculator, I bet you will not get negative 597, negative 122y. Bet you won't get that. So you really want to store that in your calculator and then recall. Okay? Laura, you're still not happy?
Well, that's what I did, and I got some crazy numbers.
Well, that's what I'm saying. Did you use negative 0.588002635?
No,
That's what you stored it? I need to take a look at what. Did you get negative 0.588 for the angle? Did you use protection properly?
I thought I did right.
Okay, so we need to check that out and see how that's going. Okay? All right. Next one was what?
95.
95. Okay. So 95 is on the same page. And okay, so it's the 2 root 3 plus I to the what? To the fifth? 2 root 3I plus. Okay. So notice that only this thing is raised to the fifth power. Okay. So then I will call this Z. Okay, I'll call this Z1. Okay. I'll call this whole thing Z. Okay. So Z1 is going to be what's R equal to?
No.
2. And what's the angle equal to? It's B over A, root 3 over 3, so that looks like pi over 3. Pi over 3? Is everybody with me on this? Yeah? Pi over 3. Does everybody agree with me on this? Josh? Yes? Ian, you don't look very happy. Wait a minute. Theta is equal to tangent inverse of 1 over root 3, which is tangent inverse of root 3 over 3. Am I smoking again? Isn't that 60 degrees? No, wait a minute. Isn't that 60 degrees? 60 is pi over 3, dude. Yeah, isn't that what I say? I don't like triangle stuff. That's too. Yeah. I mean, you guys know that this has got to be equal to 1/2 over. No, can't be 2 root 3. It's got to be root 3 over 2 over 1/2. Oh, that doesn't work either. 1/2 divided by root 3 over 2. Yeah. So that'd be 30. That'd be pi over 6. You're right. Thank you, Ian. Okay. So everybody caught up with us here? Okay. Well, you got to put down Friends table. That's the bottom line. Okay. So put down the Friends table, work it out, and see that it is pi over 6. Yeah. I mean, if you want triangles, you do triangles. I don't do triangles, frankly. Okay. I do Friends tables. Okay. All right. You guys with me on this? So this is going to be cosine pi over 6 plus I sine pi over 6. All right? So that's Z1, except I need to do this to the fifth power now, right? So everybody with me on that? So then this is going to be to the fifth power. Right? Including the